Find the range of values of k for which the line, okay, so this is a line because it can be expressed as y equals mx plus c, intersects the curve. This one, why is it a curve? Because there's a square term here, square term and all that. Even if you have xy is a curve. And this k is a constant. Now the condition is that there are two real and distinct points. So this is a case again, you have to use b squared minus 4ac, the discriminant. Alright? And the way to do it is you need to express this with y the subject. Alright, be careful, don't make any mistake here. So you can call this 1, and during exams, the question will be here, you'll be given a blank space here, right? You can actually do this, don't need to copy this here, waste time. Number 1, waste time. Number 2, you may copy wrongly. So as much as possible, as I always mention in class, the less you write, the less mistakes you will make. Okay, so the less you write, the less mistakes you will make. So the equation is already here. There's no need to so-called do any manipulations, right? So you can call this equation 1, which you have already manipulated. This one you can just label it as 2 on your question paper. Okay, then your next step you can just say sub 1 into 2. Then you don't have to copy this and then risk copying it wrongly. And what you need to do here now is to show this substitution of 3 minus x into this equation 2. Make sure you copy correctly, otherwise all your subsequent efforts will be wasted. And expand this correctly. Those of you who are still writing 3 minus x times 3 minus x, then you have to do another step to expand and then get here, right? Can you now cultivate this habit? Square this, then it's plus x squared, right? Then this times 2, so it's minus 3x times 2, which is minus 6x. Okay, this is like the maximum amount of steps you should have. Like you should not have another step here to show 3 minus x. Okay, shouldn't. But if you really need to 3 minus x, then can you do the side working here? Meaning you 3 minus x here. You will actually get the same answer as me. Then you continue from here. Alright. Now next step is to expand this and be very careful, especially if there is a negative sign here. In this case there isn't, so it's actually pretty straightforward. After that, remember that your right hand side must always be 0, and we must always express it in the form ax squared plus bx plus c. Alright, why? Because we need to find the roots. The condition is two real and distinct roots. And real and distinct roots means, if you remember your quadratic formula, which is actually found on the formula sheet in your A Maths exam page 2, this is your discriminant, okay, the one inside the square root. So let me just repeat, if it is 0, that means this whole thing is gone, there's only one answer. That means tangent, the line is tangent to the curve, or there's real and equal roots. If this is less than 0, then there's no real roots. That means no intersection. Okay? And the final case is two real and distinct roots, which is there's a positive answer for b squared minus 4ac, and that's why the condition is b squared minus 4ac more than 0 for two real and distinct roots. Alright? You can now substitute. Be very careful when you substitute. Your b is minus 14. b is the term with only x. Okay, and so that's minus 14. The a is the term with the x squared. And the constant term here in this case is this whole thing here, 18 minus x. Oh, sorry, 18 minus k. And once you have, press the calculator. Be very careful here. Minus 12 times 18 is this. Minus 12, okay, this is minus 12 times minus k is plus. Alright, after that, then you do your necessary. Some of you are quite weak in algebra. You don't know that you have to divide by 16 here. So let me just remind you. You don't want 12 here, right? So you divide by 12 here. If you divide by 12 on the left, you must divide by 12 on the right. And because you are dividing by a positive number, no need to flip. Only when you divide by a negative number or times a negative number to both sides of the equation, then you flip. Alright, so that's your answer. Now, to end off this video, I would like to tell you that Another way to phrase this question is this here, okay? Phrasing I wrote here. Find the range of values of k for which has real and equal, two real and distinct roots. Now, this question is the same as this question. Okay, you must be able to recognize that. Why? Because this question, actually, can you see that they wrote it as everything in terms of x? There's no y at all. Okay, so this is like the equation that you need to solve. Alright, but they're not asking you to solve this equation. They're asking you to find the range of values of k for which this equation has two real and distinct roots. So when it's phrased like that, they are actually still the same thing, wanting you to find b squared minus 4ac greater than 0, okay? But you need to transform or change this equation into the ax squared plus bx plus c equals 0 form before you can use this formula. I mean this b squared minus 4ac condition, the formula. Okay? So what this means is that you start from this step here. You start from this step here and then you continue. So don't need this step. Don't need this step. That means they already make you start here. So the solution is exactly the same as what I've just gone through. Okay? Can you mull over this? If you don't understand, you can ask me.